Yeah.
Okay. Alright, so welcome everybody today. Today with me I have Dmitry, Yastremskiy, and Edwin. They're both research assistants at CDOT, the Center for Development for Open Technology here at Seneca. Just a little bit about both of them. Dmitry is a recent graduate from the Computer Programming Program at Seneca and current research assistant at CDOT, working on 3D graphics development using WebGL and 3JS. A geek, a sci-fi fan, and an HTML5 believer. And about Edwin, he is a student at Seneca College's Computer Systems and Technology program. He is working on Seneca's CDOT research team on web 3D graphics, and he enjoys playing the saxophone and keeping up with the latest technology. Guys can take it away.
All right. First of all, welcome. I'm very happy to see all of you. And I think we've targeted the right audience. I see a lot of young guys trying to get into 3D here, and I think we have a presentation that you guys will enjoy. So my name is Edwin, and this is my partner, Dmitry, and we work on 3D web graphics at Seneca CDOT. We've made a presentation today on the 3D world. In this presentation, I look to go and delve into how 3D has evolved over the years, as well as the tool that we have been using, and hopefully give you guys a very good idea of where 3D is going, why it is good to develop 3D, and hopefully jump into it. So a few things to keep in mind throughout the presentation. I'd like to say that, so with 3D graphics, there's quality and performance, but I'd also like you guys to keep in mind how usable it is. That is something that we've been focusing on for the developer to develop it, as well as the user to use it. So easy to use, not a lot of overhead for the user as well. So let's jump right into it. Table of contents, high overview. I have to start with a brief history so that you guys get a better idea of how far we have advanced and why we're doing better right now. 3JS is going to be the main core that we're talking about in this presentation. It's the tool that we use. It's open source. It's really good, and we hope to, by the end of the presentation, give you guys an idea of why you should use it as well. Open source and how it pertains to us, how we take advantage of it. 3D basics. This is oriented towards how to get your hand developing your own 3D app, and then we'll show you guys some cool examples that use 3JS. So, if you guys have touched web development a long time ago, 3D graphics that use the GPU, Java applets were one of the first. Nowadays, GPU are very powerful. It would be kind of stupid not to use GPU. So Java applets back then on the web, swing class and AWT class, that you guys have developed for it. It was good, but not so good. Java runs on a virtual machine, Java JVM, but it is cross-platform, so that it's got some good things going for them. We'll take a step forward, and the next big thing that came up was actually Adobe Flash. We still see some of that these days, but you know, it's got its perks. Oftentimes you boot up your computer. Do you want to update Adobe Flash? You get pop-ups. Do you want to, it's requesting permission. We view that as not very friendly for the user side, and it's got higher upkeep. Moreover, Adobe Flash is proprietary, so it is pretty hard for it to become an open standard. So we're gonna move on and talk about the next big step, which is Open WebGL. It uses OpenGL, and developing for these two are actually not very developer friendly. So when I talked about developer friendly as well as user friendly, but WebGL lays a foundation for many web tools that we're using nowadays. And I'm going to get into that in a bit. I'll also show you guys some code fragments later on to show you guys the difference. So in here, I want to emphasize that WebGL uses OpenGL ES, which is ES stands for Embedded Systems, and if you will move on to the next slide. Web 3D graphics today. So for those of you that have been using browsers or playing games, you might be familiar with Unity. Unity is a game engine at heart, and when they do web browser games for you to play that uses Unity, you need to install this Unity plugin, which not very good for the users as well. It's one of the things that has been keeping it slow for a bit, but in 2015, they are developing a way to export straight into HTML, so you don't need to install this plugin for you to get it to work. Babylon.js is created by a few minds at Microsoft, and it's also a game engine, and it's newer than 3JS, which is our main topic we're going to talk about today. And it's new, but we're focusing on 3JS today, and we hopefully start talking about 3JS. So 3JS is a JavaScript library. Mr. Doob is the creator of it, and he puts it on GitHub. It's open source, and he put it there in April of 2010. There is a website for it, and there's many cool examples on that site. We'll be showing you a few near the end of the presentation. And why we think it's so great is because of the factors that I talked about in the beginning. It's pretty easy for the developers to start creating a working application for it. And also for the user, they don't need to install any plugins. They don't need to upgrade 3JS. They just use their browser, and the browser natively supports it. And also, this is based on WebGL, which I talked about a little bit earlier. Okay, so here it looks like a lot of code, but in comparison, it's actually not that much. I'm just going to highlight this line right here to get you guys to pay some attention to, because I'm going to be doing a compare and contrast later on. So this box makes a geometry, makes a box, and has X, Y, Z, like 3 values saying how big is it in its X, Y, Z. This whole page is all that's needed to create an app, and I will be showing you on the next slide how it looks on JS Fiddle. So as you can see, the code is what we saw on the previous slide, and here we have it. It's a box. It rotates. It's pretty much the whole app. It's a little bit laggy for some reason, but it looks a lot better. So this is just an example. I know there's a lot of stuff that's not very familiar to you guys right now, but Dmitry will be talking about them later on in his half of the presentation. Moving forward, when I told you that WebGL and OpenGL was very not that friendly for the developer, this is a taste for, you remember that one line I highlighted on 3JS? This is its Greek equivalent in WebGL. So I'm not going to go into too much detail, but as you can see, it's like a 1 to 100 or something. And last topic I wanted to briefly touch on is open source and how we have been interacting and taking advantage of it. So 3JS is an open source library. It's hosted on GitHub. And through our project, we've had to use parts that weren't part of it. And this is where open source beauty comes in. There's many open libraries for interacting with JavaScript, and we have found one. It's called CSG, which is Constructive Solid Geometry. And what it basically means and lets you do is there's Boolean operations that we needed, like union, right here, which is adding 2 objects together. Subtraction, subtract one from the other, or the intersect, which are pretty well defined in math. And we were surely glad that we didn't have to write a library for it because it gets pretty complicated. To give you guys an idea, when you have a lot of points in three-dimensional space, sometimes when they interact, those points weren't in your data set to begin with. You had to do some crazy math, I'll call it, connect lines, interpolate to subtract the shape that you actually need. So this is just one of the libraries that we've been using, and we've had some successes. Like it's been a very nice journey so far. Moving on, I'm going to pass on to my partner, Dmitry, to talk about the basics of 3D.
Hi everybody, just in addition to what Edwin said, why we chose 3GS, because actually it has the biggest community among all other 3D libraries available today. There's tons of extensions already, lots of things written for them, and it's in active development. So we really believe in 3GS. So I'd like to give you a brief explanation of 3D basics. So in this part of the presentation, we will be targeting more people who are new to this area. And at the same time, we will try to show how simple it is to create things in this library particularly. So to start with, from the school, we're all used to a two-dimensional system, which is X and Y. In 3D world, we get in the third dimension, which is represented by a Z-axis, which actually gives us a depth of the view. In fact, what we see usually on your screen is a 2D picture, and the depth gives us an illusion of 3D. So coordinates, any point in the 3D world is represented by three values, X, Y, and Z. So for example, this brick, I would call it, this point will have coordinates 2, so it will be 2, 4, and 5 on the Z-axis. So this is the very basic thing that you need to know. So as any show starts from the scene, we need to create a scene in order to place something over there. The scene actually stores all your objects of your 3D world. This line of code will allow you to create a scene. So now, since we have a scene, the next important step is actually a camera. We can't really see without eyes, right? So our in 3D world, our eyes is camera. We need to set up camera in order to see our 3D world, and typically there is two types of cameras available. One is called orthographic camera, which is on the right side. You probably saw it a lot in old strategy games. And the most common is perspective camera on the left side. So in order to set up camera for your 3D world, all you need to specify is the angle of view. So for human, it's usually 40 degrees, but it's up to you what angle you would like to see. It's the same way as lens on the camera give you different angles. Then you need to specify aspect ratio of your skin, so window, inner width, inner height will give you that. And then you specify near clipping and far clipping, which allows you to see how near you can see and how far you can see. So our camera is done. Now we need to position it as any other object in 3D world. We have to give it position, any coordinate, and add it to scene. So our camera is ready. The next step is actual objects that we would like to see in our 3D world. 3GS library has a set of pre-built shapes for you, as well as you can create your own shapes, or you can load models externally. In this example, I'm using a pre-built shape called box geometry. So first of all, any object consists of two things. First is geometry, and second is material. By combining the two, you get the actual 3D object or mesh. So on the first line, we specify the geometry of the box and give it dimensions, basically the height, width, and depth of your box. The second line is we specify the material. In this case, we specify the texture that you see on the cube. Again, it's very easy. You just call this specific function and give it URL to access the texture. And then you create a mesh out of it, simply combining geometry and material. Then you add your position object as any other objects in your 3D wall and add it to the scene. The next step, as a human, you can't really see anything in complete dark. Without light, the same way you can't really see anything in 3D world without light. So we need to add light to it. There's many different types of lights available. Spotlights, global lights. So here as example is directional light where you can target specific objects with the beam of light. Here how you create light. Again, it's one line. You specify what type of light, give it color, then you position it in your 3D world and add it to scene. Extremely simple. So far we saw just static pictures of our 3D world, but it would be much more interesting if it will be, actually the scene will be animated. So how we can do it? Basically how it happens, you move the object per unit of time. As a standard, in rendering used 60 frames per second. So what we need to do, we need to move objects 60 times per second in order to get smooth animation. So how we can do it? We need to call the animation function 60 times per second. It's perfectly fine. It's not a problem to call it. The problem we can encounter when your scene become heavy to rendering, for rendering, and your browser actually can crash because of it. So all the modern versions of browsers released an API called request animation frame. By calling this function recursively, you pass control to the browser of the frame rate. So it will try to make sure that your animation runs smoothly at 60 frames per second. Or it will slow it down in order if your scene is too heavy, but do not crash your browser. So this function is very helpful and gives us kind of confidence that our app will run smoothly. And this line, we specify actually how we're gonna animate the object. So we're saying that our cube will rotate along the axis. And here we specify the velocity of this rotation. And this function will be called roughly 60 times per second, so you actually see the animation. So any animation done this way. The next very important part of 3D world, we would like to actually interact with this 3D world, move objects by cursor or any other way. So ray casting helps us to do so. What basically happens, you shoot a ray from your camera or maybe from your cursor pointer to the needed direction. And if this ray hits any object on the way or the array of objects that you specify, it will return data such as position of this object in 3D world, the name of it, distance to it, and the face that where the intersection occurred. Basically, this way done all the interaction in 3D. And here I'd like to show you just a simple demo. Here you can see there is two types of light. This light is global, so basically it highlights the entire scene. You can't really see edges of the cube. This light is usually used with combination of other lights. And for example, here now you see the directional light. So it's it casts a beam somewhere from this point, so you can now distinguish all the edges. Another thing that I've talked previously is animation. So this is the animation, how it's done. We basically add a small number to the rotation, so it starts to rotate. Very easy. And the last thing that I would like to show you in this demo is the actual ray casting, how we can interact with the object. So basically I'm clicking on the object and it changes the color. So how it happens, at the point, of course, it shoots a ray which hits the cube. And what I'm getting back the name of the object, and I can manipulate with it. For example, now I can change the color of it. So it's a very simple idea. So what is cool about this library? There is lots of interesting things in development currently for 3GS. For example, support of different controllers, gamepads, or lip motion. I'm pretty sure some of you are familiar with such controller. And I just want to quickly show you how you can, there is extension available. You can easily attach lip motion to your app and interact with your 3D world. It's awesome. And another cool thing that I wanted to show you is actually you can create support of virtual reality helmets such as Oculus Rift, or for example, I'll show you in the full screen. Just a moment. So it is, sorry, the resolution is bad. But at least you get an idea that actually you can use Oculus Rift or Google Cardboard or any other coming out VR helmets, and it's pretty easy to do it as well. So there's lots of potential in these things. And the last thing I want to show you some demos. How is 3GS library used? For example, by the way, Google uses 3GS in their Chrome experiments. For example, this is how you can represent data in 3D. This is a weapon traffic in the world. Probably see where the most ever coming from. So it's really interesting to represent data. Right? And they're smoothly, beautiful. Another use of it is actually on your web page. Now you can use it as part of your web page, and this website gives a really good idea how that happens. So this graphics done is 3GS on top of the web page. I think it's beautiful. And this here's your website. They made some interaction, so it looks pretty cool. The next, the latest example that I would like to show you is what you can achieve in graphics quality and details. It's an example. So as you can see, it looks pretty naturally and even a little bit scary. We were staring at each other for a long time. So this is what we want to show you today. And please, if you have any questions, I'd like to answer them.
How do you implement any physics effects when deformable body, things like that?
Well, there is libraries available which gives you those physical motions. As I mentioned before, there's lots of extensions available for 3GS. One of those is actually physics you can implement. Fortunately, I have an example, but there is lots of examples with physics.
I'll maybe extend upon that a little bit. So as you can see, when you did the light, the sides, the faces of the cube that weren't facing the light were automatically darker. So that's not maybe physics, but the beauty of 3JS is a lot of these calculations, and if you were to do 3D mathematics, or like if you had to calculate the function to transform the shape when it's moving, that's not stuff that we want basic developers learning 3D to have to go through. 3JS gives people that don't have a lot of math background or a lot of 3D understandings to just jump in and start doing things. If you require higher physics, there are libraries, but built in, you don't actually have to do a lot of code, and it takes away a lot of that harder stuff away if you don't need to deal with it.
Well, the animation you showed is just basically transformation matrix. You apply different transformation. That's it.
Yes.
Change orientation in space.
Yes.
But if you want to move nodes of the objects separately,
Bouncing
how
and
you,
stuff,
how
you
do
mean?
Yeah, there is like you can morph your mesh like to create a movement, let's say, of the human, or there's a library called Twin, which gives you it's called twinning from in between, so it gives you different values to make sure that your transition is smooth and using different formulas. So again, lots of things available. You can implement wherever you wish in 3GS.
How to compare the performance of this with the older technologies like OpenGL? Okay, will it run on the commodity old hardware? Will it give us a seamless performance?
WebGL is fairly new language. It doesn't have full access to your GPU. This 3GS library they're still work in progress. They're trying to optimize it as much as you can. So for example, you can merge geometry of the entire scene, and you can have like 100,000 objects run smoothly. It only matters how you implement things, but well, obviously it's not that performant as you would run a standalone app accessing your GPU through the OpenGL, but it's improving dramatically.
It's a performance story for web browser support for GL is constantly ongoing. You see Chrome, Firefox are constantly battling each other up for GL with.
See, the fact the browser is another thing because ultimately things run in the processor, and
Yeah.
This is kind of a higher level of abstraction because you have a better library. You can write a code in 2 lines which earlier required 50 lines.
Yes.
And that always comes at some cost
Overhead.
of performance,
Yes.
some overhead. So I was just curious to know if there is any measure of overhead.
I don't have numbers for you, but at the same time, when you're running code in a controlled environment, it solves issues like security that you don't have to figure out. So it's a trade-off, I think. And so far, we have loaded a little bit complex models in there, and we have not taken huge performance hits in our opinion. So you in the back there?
As a junior developer, is there anywhere where I can see like the more the OpenGL code running in the background? Like, can I use the console view? Because you're writing kind of short, like the actual access.
Not sure.
Not too sure about that, but because this sits on top and converts it into the WebGL and the OpenGL. I believe it's been abstracted away, but if you your console, you can still get relevant information that you can log. Yes, the console is fully available. So
You can use WebGL together with 3GS shaders or however you wish it works together.
Does 3GS perform well on mobile devices?
That's good.
I think so. I've been able to load stuff on the phone even, and I've even tried like Chromebooks. Well, it's not really a mobile device, but I've seen very good support for most devices that runs Chrome right now.
And now WebGL is supported by all the major browsers, including Apple, starting iOS 8. So when Microsoft Internet Explorer will start in i10. So there is no problem to run it on any browser, any device these days.
What's the time frame you're looking at for this to be fully functional? 1 year down the line? 2 year down the line?
What do you mean
Like
fully
the
functional?
browser support is, still.
Been around for years already.
They've been up for years.
It's been functional. This is functional.
No. I think you mentioned that the browsers are still improving for supporting this.
Right.
So
with each browser and with each version, they have to pass tests, and most of them are 90% or 90 something percent. IE might be a little bit slower, but they look pretty functional right now.
Browsers like to implement things differently, so there is some issues sometimes, but overall,
90%.
there's some fallbacks also available. Instead of WebGL, you can use Canvas render or even CSS 3D render, so it's actually evolving a lot.
Are there any issues of contention between different browsers about the features? For example, HTML5, and you see lots of debates about various HTML features between the developer community for Mozilla or IE or Chrome. Are there any issues of contention from the browser developer's perspective?
Well, the issues so far that we have encountered was only in the interpretation of events,
Right?
but it's more not WebGL related, but the interaction with your mouse or some other events. WebGL itself, there is no difference in the browsers how it is displayed.
Because they're standards, that's what.
The standard.
Yes, right.
Oh, that's what. Are there debates over the standard? No, sir, no debates.
We didn't encounter any issues so far, so it's really hard.
For the most part, it works. You could tweak it. Sometimes you see a bug, but we haven't encountered too many of those. Like I said before, so far it's been a pleasant experience until now. Some more questions? You in the back, sir.
What's the benefit of rendering 3D objects and environments in a web browser as opposed to on like a local executable?
So an example I can think of right on the spot is you're working for a company, you have a browser, but are they going to let you install executables to view something? So that's one thing. browser is also very cross-platform. I mean, most platforms have a browser, and you see Google makes their Chromebook. Like they also view the browser as where we should be going, and I think it's a very versatile platform, and I think it's a step in one of the correct directions. Hope that answered your question.
Thanks.
Yes, sir.
Do you have any control how data handled by GPU, or this is all abstracted through the API?
What levels of?
Well, I mean, can you control how GPU handles your processes, your data?
Probably not.
Not really. Just VGS gives you easier way to create things. But if you wanna access it directly, you use WebGL language for that. So there is much more control.
WebGL provides such features.
Yeah. Yes. But it's more deep level.
We didn't have to, like, we might be wrong here. We didn't have to look that deeply because we were using, like we said, a high-level tool aimed at beginner developers. I have a feeling even OpenGL is just an API, so you just make the correct API calls. So if you're looking at a new way to interface with the hardware, I don't think this is the correct place to look at. Yes, Kat?
Just a comment. WebGL is OpenGL-ES, JavaScript bindings to OpenGL-ES. It's basically that. So if you're looking to write OpenGL code, you're doing WebGL. That's pretty much all it is.
I think it's a different scope we're looking at. Like, this is aimed towards easy content, fast creation, easy for people to learn, lots of results. But if you want very hand-tuned optimization, very low-level stuff, this is not quite it. But that's not really the focus of the web development part, I think. So it's trying to bridge the gap for people that, oh, 3D is so cool, let's do something. But I don't know anything. What's the best way to learn? So.
Well, thank you from everybody here for your great presentation, Dmitry and Edwin. We have some gifts from you from the FSOSS committee.